Hey guys, it's Rico here. Today I'm gonna be doing a quick and simple tutorial on a Matlab function that we could all use. First of all, I just want to give credit to Dr. Katz for providing us with this tutorial. Anyways, right now I am currently taking ECE 350 Linear Systems and Signals class, and we are talking about Fourier series and using Fourier series to represent a signal as a frequency function rather than time function. As we all know, we can easily analyze a signal in the frequency domain rather than in the time domain. Therefore, the Fourier series is very helpful to us. I am going to be talking about the exponential Fourier series expansion type, and which I find is easier than the other form of Fourier series expansion. So, for example, we are given this waveform, the signal right here. We can break it down using the exponential Fourier series, which yields us these equations down here, f of t and f of n. F of n are the coefficients of complex exponentials in the function. We can now therefore use Matlab to find the coefficients of complex exponentials of f of n. And now, since they are complex coefficients, we must plot them separately. We must plot the magnitude and the phase of f of n separately. In Matlab, we can use the ABS absolute function to find the magnitude of f of n, and we can find the angle command to find the phase angle. In this example, we can see that our period is 7, so t equals 7. Our omega naught is equal to 2 times pi over 7. And now we're going to be using the symbolic math toolbox function of Matlab, SYM sims function. So basically, you are just transferring these equations right here to the Matlab equations and plugging in your variables and the known values here. We have to take into account f of 0, and we need to take into account separately. So we plug in 0 for n and plugging it back to the equation here of f of 0. So basically, these values right here are just the ranges of values in your graph. We have the positive n harmonics to be from 1 to 10, and our negative n harmonics from negative 10 to negative 1. As I said before, we could also plot the phase angle of f of n by using the angle command. And so basically, we can just run this code to Matlab, and we are given this subplot right here. And the top, you can see this is the magnitude of f of n. You can see the harmonics. You could analyze each component of a harmonic, and into the signal can be from the output, from the input, and also we can plot the phase angle down here at the bottom. So it makes it easy for us to analyze each signal in each waveform. So luckily we have Matlab to help us find the coefficients, because as you can see from the formula, the integrals can be tricky and it can take a while to do them by hand. But with Matlab, with simple commands, it takes us a fraction of the time to do it. And so, hopefully you guys learned something new about Matlab, about Fourier series, and using Matlab to make your life easier with all the calculations, all that stuff. So thank you for watching, and peace.